I would like now to introduce to you today to our two speakers, Dr. Catarina Marques and Professor Robert Tozer. Now, Catarina is a senior research fellow at London South Bank University and project manager for this project. And she has her expertise in local smart energy networks and combined heat and power, whilst Robert is Director of Operational Intelligence and one of the most prominent data center cooling experts. So I'll now pass you over initially to Catarina, and then later on Robert will also be speaking. So to you, Catarina.
Thank you, Dermot, for the introduction, and I would also like to thank the Institute of Refrigeration for the opportunity to present on the GreenSCIES project. So I will start by introducing fifth generation energy networks that combine heat, power, and transport. I will then describe the GreenSCIES concept and our design approach. And we'll also show you the results of the techno-economic model that predicted the carbon emission savings for the network. Robert will then cover in more detail the heat recovery from data centers, and he will also touch on the key benefits, challenges, and risks of connecting data centers to fifth generation networks. And finally, we'll conclude with the results of the feasibility study and the next steps on the project. So why GreenSCIES? Well, the background to the project is the government clean growth strategy that sets out a significant role for heat networks, and also the target to reach net zero carbon by 2050. So heating and transport, they are the highest carbon emitters, and together they represent 64% of the UK total emissions. So our project, GreenSCIES, it stands for Green, Smart, Community, Integrated Energy Systems. So that's quite a mouthful. That's why we always abbreviate to GreenSCIES. And basically, what I'll present today is the results of our feasibility study in the London Borough of Islington. So just a bit about the innovation behind the project and why fifth generation networks. Well, looking a bit back in history, this chart shows you the evolution of district heating networks over time. So traditionally, there were high temperature networks powered by fossil fuels, and they had a centralized energy center distributing heat to multiple buildings. Over time, the temperature of the networks has reduced and their efficiency has increased. So in the latest fifth generation concept, the heat network is at ambient temperature, and it has several decentralized energy centers with heat pumps, photovoltaics, electric vehicles, thermal storage, alongside large-scale batteries. But one of the biggest advantages of fifth generation networks is that because they are at ambient temperature, they can recover waste heat from local sources, such as canals, cable tunnels, and a variety of many other local heat sources. So these fifth generation networks provide an integrated system that delivers low carbon energy. And these are some of the key aspects that we looked at during the feasibility study. So we looked at system integration, we looked at the smart control of the whole system, we looked at vehicle to grid integration. We also even looked at new business models and even policy recommendations that can enable these 5th generation networks. So just on the GreenSCIES concept, well, it's an integrated heat, mobility and power network. And you can see the infographic that summarizes the whole concept. So in Islington, the 2 main waste heat sources are the London Underground ventilation shafts and also local data centres. So both the London Underground and the data centres have large cooling demands. So their heat can be recovered into the district heating network. So the network also integrates photovoltaics, electric vehicles, thermal storage, and the batteries. So the whole system is controlled by artificial intelligence that provides the demand side response for the system. So the 3 C's for GreenSCIES are community, clean, and cost. So it's delivering low-cost, clean energy to the local community. And this was the scope for the study in Islington. So there was actually 2 schemes in the network. So there was this south scheme that you can see on the map, which had heat recovery from the data centres, and the north scheme had heat recovery from the London Underground. So the red line shows the proposed network route, which is about 2 kilometers in length, and it connects 16 energy centres. Now, this scheme can also link to existing networks nearby, which are shown on a map in green and in blue. And that's, we are investigating this future connection. So overall, the 2 schemes, they connect over 10,000 residents, 10 businesses, and they tackle fuel poverty for more than 2,000 residents. So this was our approach. We carried out energy mapping and a SWOT analysis of the local energy sources. We did site visits, we cycled the proposed network route, and we organized workshops to engage the local community and local stakeholders. So this diagram that looks a bit like spaghetti is actually a representation of the techno-economic model. So it basically shows the technologies on the left and the anchor building loads on the right. So the techno-economic model, it estimated that the carbon savings of the network and also the operational expenditure. So we model several scenarios in the techno-economic model, and the idea was to compare a baseline case with existing gas boilers compared to various technologies. So we looked at heat pumps, thermal energy storage, PV, vehicle-to-grids, and bespoke batteries. So we looked at a combination of these technologies. And the results show a 1.6 million operation expenditure savings per year compared to today's baseline case with existing boilers. So option 6 on the chart is the one with the highest OPEX savings, and this is the combination of all the technologies. So the model also estimated the carbon emission savings, which are 80% of today's baseline with existing gas boilers. Now, as the grid decarbonizes further, this would tend to 100. So the carbon savings over time will increase. So This is an integrated energy system that reduces carbon, it delivers significant revenue savings, it tackles fuel poverty, and it provides a 10-year payback, which is quite attractive. And we have identified a funding pathway to demonstration. So we have a route to actually build this network.